Good evening, students. I welcome you for another important session. And this is going to be the last topic of the gravitation. In the gravitation, we have told you the laws of the flotation that if a body has a more density than water, it sinks. If a body has less density than the water, it floats on the water. Today's topic is very important because today we are going to talk about what is density, student. Our topic of the day is density. This is very important. As you learned, as you learned that what is happening, students, objects which are heavier, which are denser than water, which have more density than water, they sink in the water. And those objects whose density is less than water, they float on water. So we discussed about that. Now question before us is, what is this density? What is this density, student? You have experienced, if for example, if I take same volume, if I take the same volume of iron, if I take the same volume of aluminium, student, and if I take the same volume of mercury, and if you take the same, I'm saying same volume, the volume is same. If you take the same volume of mercury, if you take the same volume of cork, student, if you say take the same volume of water, some of this will appear heavier, some will appear lighter. Yes or no? Do all will appear have the same weight? You will find what you experience, student, what you experience, certain objects, certain substances which I have listed here, and certain substances, if I have listed elements posing here, they are they are heavier than others for the same volume, I'm saying, for the same volume, you will find that iron appears heavier. Iron is appearing heavier as compared to water, or iron is even heavier than aluminium, student. If you will experience, if you take the same volume, then the different substances are having different heaviness. That means, student, we have to define a quantity which is called density, which will be measure of the uh, how much heavy a substance is, how heavier a substance is, as compared to supposing water, as compared to, if I compare it with water. So if I want to compare with water, if I say water, I want to put something in water. So you are saying certain substances of the same volume have more mass. Therefore, student, what was done was that we define density as, what is the definition of the density, student? Mass of the substance. We define density as mass of the substance divided by the volume of the substance. Volume of the substance. I am saying we are defining a quantity density d, student, d, which is nothing but mass of the substance per unit volume. So mass per unit volume is called the density of the substance, student, density of the substance. In other words, what I am trying to tell you, that supposing here I am taking certain substances. Supposing I take cubes, I am taking cubes of 1 meter. 1 meter cube means length is 1 meter, breadth is 1 meter, and height is also 1 meter. Supposing I make a cube of, this is my iron. Then I make a cube of 1 meter, 1 meter cube I am making, student, of aluminium. This is also 1 meter, 1 meter, 1 meter. And then you are making a cube of 1 meter, 1 meter, 1 meter cork. Then you make a cube of then you make a cube of 1 meter, 1 meter water. Inside this you have water. So we are taking different substances here or elements. Volume I am keeping the same. What I have done, student, I have kept the volume same. They have the same volume. How much is the volume? How much is the volume of each? 1 meter into 1 meter into 1 meter. That will be equal to 1 meter cube. The volume is 1 meter cube. 1 meter cube of iron I have taken. 1 meter cube of aluminium I have taken. 1 meter of cube of cork I have taken. 1 meter cube of water. Now I measure their masses, student. I measure their masses. What I will do? I measure the mass. So I am measuring the mass of 1 meter cube of each substance, student, in kilogram. In kilogram. I am using kilogram because the SI unit. What will be the SI unit, student? Mass. What is the SI unit of mass? Kilogram. And what is the SI unit of the volume, student? Meter cube. So, student, these are the SI units of the density. This is the SI unit of the density kilo. Now I have cubes of 1 meter cube, student, of different substances. And what I find, student, these are I will weigh them. And what I find for iron, the mass is 7800 kg. The mass of 1 meter cube of iron is 7880 kg, students. And for aluminium, it comes to be 2700 kg. Mass of 1 meter cube. This is the mass of one. What is the volume? 1 meter cube. What is the this is the mass of aluminium. What is the volume? 1 meter cube. And this is the mass of the cork, students. The mass of the cork, if we will see the value of this, which is given in the book, student, this is coming to be 1 meter cube of cork will weigh 240 kg. The mass is coming to be 240 kg. And the mass of water is coming to be 1 kilogram. 1 kilogram. The volume is same, 1 meter cube. 1 meter cube. ठीक है? So I am measuring the mass of 1 meter cube of different elements or substances here. Or if I take ice, student, you know ice. If I take piece of ice which is also having a volume of 1 meter cube, 1 meter, then we will find the mass of this ice is coming to be 920 kg. Therefore, students, if I take the same volume of different substances, are their masses same or different? Tell me. Are the masses same or different? Tell me. If I take what I am doing, I am taking the same volume of different substances. How much? 1 meter cube. Their masses are coming to be different. Their masses are coming to be different, students. How much is the masses coming? Different. So what it will mean that this which is heavier than, which will appear heavier, same volume, for the same volume, which is having the largest mass here? Tell me, which is having the largest mass here, students? Volume is same, but mass is coming to be different. Mass is coming to be different. If I will take mercury also, supposing you take mercury, I have written here mercury also, student. If I take mercury also, students, and if you take 1 meter cube of mercury volume, the volume I am saying is same for all. How much? I have mercury here. 1 meter, 1 meter, 1 meter. And if you take mercury, student, you will find the 1 meter cube of mercury will weigh 13600 kg. So what is important point here, student? What is important point? That I have taken different elements or substances. And I have taken the same volume, but mass is coming to be different. And that is what we have, that is the reason we have defined density, because some substances are heavier than others. You are saying iron appears to be heavier than water if I take the same volume. If I take the same volume, that is why the density has been defined. So what will be the density of the iron here? The density of iron will be how much? 7800 kg per meter cube. So this becomes the density of the iron. Density is defined as mass per unit volume, student. And if I compare this with water, water density is how much? 1000 kilogram per meter cube. 1 kilogram, not 1 kilo. This is what for water you are getting 1000 kg in kilogram. This is 1000 kilogram. Okay? So water density is 1000, mass of the water is 1000 kg. So what will be the density of the water, student? Then what is the density of the water? So this is a method by which we are calculating the densities as mass per unit volume. One thing is very clear that as you have experienced that certain objects are appearing to you lighter, certain objects are being heavier. So some substances appear heavier to you, some lighter because their densities are different, student. What we have to say that, what I'm trying to say that different substances have different densities, have different densities. That is why substances which have higher densities, student, higher densities, they appear heavier. They appear heavier to us. They appear heavier. So you are saying iron is looking heavy as compared to aluminium. Aluminium, same volume you take, it is lighter because the density of the iron is more than density of the aluminium, student. So here the density is an important thing, and density of a substance we have defined as mass per unit volume, mass per unit volume, and the SI units of density, student. What I have given SI units of density as mass per unit volume will be kilogram per meter cube. But this is a large because this SI unit is large in quantity. So we define another CGS units also, student, which is density will be then mass per unit volume will be what? Kilogram will be gram divided by centimeter cube. So we may be using in our books and many places gram per centimeter cube. So we can use different units for defining the density, students, and you will get a table in which the values of densities are given. Densities are given in your book. For example, if I say if I say cork, student, the density of the cork is given to be 0.24, 0.24. This is for cork. You are given a density of 0.24 gram centimeter inverse, and you are saying the density of the water is 1 gram centimeter inverse, and this you are saying the density of mercury, density of mercury, these are the densities. Mercury is, student, 13.6 gram per centimeter cube. So these are some of the values. The density of the gold, if you will see the gold is 19.3 gram centimeter inverse. So you can see that different substances have different densities. And the density of aluminium is aluminium, the density of aluminium is 2.7 gram centimeter inverse. So if I take 1 centimeter cube, if I take 1 centimeter cube, in other words, what I am trying to do here, how do you convert one unit into another unit, that you know? I will just demonstrate one of these values, how we convert one unit into another. In other words, student, what I am saying, what I have done here, what I have done, I have taken, student, a cube of 1 centimeter, 1 centimeter, 1 centimeter of each of these substance. So the volume of each of the substance is how much? 1 centimeter into 1 centimeter into 1 centimeter. The volume of each of this is how much, student? 1 centimeter cube. And I measure the mass of each of this. I will measure the mass of 1 centimeter cube of cork, mass of 1 centimeter cube of water, mass of 1 centimeter cube of mercury, one mass of 1 centimeter of gold, mass of 1 centimeter aluminum, and that I will measure. That these masses are going to be different. Each will have different mass, student. Therefore, the densities will also be different. Density is mass per unit volume. We are saying if I keep the volume same, if I keep the volume same, then the masses are coming out to be different. Therefore, they have different densities. They have different densities. So density, if I say the volume is same, then density is related with the mass of the substance. In other words, the substance which has more mass per unit volume, the substance which has more mass per unit volume, will have more density, greater density, will have greater density. Why will some substance have more mass per unit volume than other, students? So you can ask me questions, sir. Why? The next question naturally is, why do certain substances have more mass per unit volume? Per unit volume. You already know the answer of this, student. Everything, the matter is made up of particles. You are saying that your matter, every substance, the matter, the substance, these are made up of the particles, student. Atoms and molecules. They are made up of atoms, molecules. And if the packing of these, if they are packed very closely, you know that if they are packed very closely, that means the attractive forces are stronger. Attractive forces are stronger between the particles, of which the substance is made up of. What will happen? They will come closer. They will come closer. Therefore, their density will increase. If you are saying, if I am saying, student, that the density of, if I am saying, student, in other words, density, if I take the density of iron as a 7, density of iron, if I take 7.8 gram centimeter inverse, as compared to the density, uh, density of aluminium. The density of aluminium is 2.7 gram per centimeter cube, and the density of water, you are saying, is 1.0 gram centimeter inverse. What it means? The particles of iron are more closely packed in a unit volume. In a unit volume, there are greater number of particles of atom. So they have more mass. 1 centimeter cube of iron, 1 centimeter cube of iron has more mass. Then it is, or in other words, this iron is 7.8 times heavier than water. Iron is 7.8 times heavier than water, means the particles of the iron are more closely packed, more densely packed. There are more number of iron atoms in 1 centimeter cube as compared to water. If I take 1 centimeter cube of water, the mass of that 1 centimeter cube of water is less. So that means they are more densely packed and their mass is more. Mass is more. You already are aware of that solids have more density than liquids, and liquids have more density than air. That you already know. We have already told you in one of the lecture, the density of solid is more. And you know what is the reason, how the solid particles were packed in the solids. These particles were very, very closely packed and very strong attractive forces, very strong attractive forces, student. So it became very, very dense, very, very dense. Whereas in the liquid, what you find, student, the particles were having some space between them, so the attractive forces were weaker. And in the gas, you know what happened in a gas. If I take the same amount of gas, the particles having weak forces of attraction and they are farther away, the number of particles per unit volume is less, number of particles is more. The number of particle is very large here per unit volume. That is why there is a difference in the density. So you will see the reason which we have given why something is more denser than other. Now, we have understood the meaning of density, that mass of the substance per unit volume. And that is why certain substances in our everyday life, student, appears to us heavier as compared to other. You can see the density of gold is very high. The density of gold, how much I have given, 19.3 gram per centimeter inward. This is quite high as compared to water. And then we have already told you in the laws of the flotation, what is the consequence of the density, what is the consequence of the density, what is the importance of density. Student, what is the importance of density in our everyday life or in our science? What is the importance of density? You already know, students, you already know. We have told you, if the density of this, if the density of substance is more than density of water, what will happen? It will sink. It will sink in water. Because density is mass per unit volume. That is the definition which we have given to you. And how do we calculate? We have shown you density. Then if the density of substance is less than water, if the density of substance is less than density of water, what will happen, students? The object will float on water. On this principle is based your ships, boats, so that they can float, because we will change their volume, so that their density becomes less than water, and they will be able to float on the water, because density is mass per unit volume. If the mass is same but volume is changed, if I increase the volume, what will happen? Density will decrease. Density is directly proportional to mass, and the density is inversely proportional to volume. If I increase the volume, density will decrease, students. So this is a very important thing. Now, if the question is, now we are aware of what is the importance of the density. What is the importance? So for a particular substance, you see, density is a characteristic property. Density is not going to change. Density of a substance is not going to change, student. Density of a substance is not going to change. If I say density of water, pure water, this is my pure water, student. If there is something else which is present, if salt is present in the water, then its density will change. So the sea water has a lot of salt and other substances present in it that may be more denser than water. That may be more than salt water will be denser than water because it has got salt present in it. So density will depend. If you have add some substances, like in the sea, there is a lot of salt which is present in the water, so naturally the sea water will have higher density than the pure water. So if I say the density of water is 1 gram per centimeter cube, student, it is same everywhere. Doesn't matter you get the water from anywhere, or you put a small amount of water or a big amount of water in a bottle, it will always have the same. So it is a, what we call as density of a substance is characteristic. It is a characteristic property of a substance. Property of a substance. In other words, students, what we are saying, pure substance will always have the same density. If I say this is pure gold, what is the density of pure gold, students? What is the density of the pure gold? This value is given in the books 30. For the gold, it is given 19.6 gram per centimeter inverse. So if you want to find the substance is pure or not pure, then what we will do? We will find the density of the gold. I give you a bar of gold. I said, is it pure gold or impure? What will you do? You find the density. And if the density comes to be 19.6, then it is pure. If density is not coming to be 19.6, student, then it is not a pure gold. It is not a pure gold. So we can use the density of a substance to find the purity of a substance. Density of a substance can be used to find the Purity of a substance, student. Whether milk is pure or not, what they do, they measure the density of the milk. From that density, they can say whether milk is pure or it has water present in it. You see, there are instruments, lactometers, which are used to find the purity of the substance, student. And one thing is clear: if a substance is lighter, then if the density of the substance is less than water, it floats. If the density of the substance is more than water, it sinks. That is clear to us, student. All right. So we have learned a lot of things about the density, and we have told you how to calculate the density, how to calculate the density, students, how to calculate the density of a substance, any substance. Supposing and supposing I say that an object has a mass of, supposing I have an object which has a mass of 50 gram and volume 25 centimeter cube, 25 centimeter cube. Find the density, find the density. Then what is the density? Then density is mass per unit volume. You have 50 gram. Volume is 25 centimeter cube. So what is the density then? This cancels by 2, 2 gram centimeter inverse. So we can find the value of the density of the substance, student. If I know the mass and if I know the volume, it is easier to find for me the density of the substance. Supposing this was my question 1, student. Question 2, for example, and what I am saying, mass of steel is, supposing mass of steel is 15,000, 6,000 kg, volume is 2 meter cube. You are given that there is a 2 meter cube of volume and the mass of steel is 15,006 kg. Find the density in gram centimeter inverse. Now we have to find the gram centimeter inverse, student. This is first, let me see how will I do this question. How will I do this question, student? Okay. Answer. How will I do the answer of this, student? Formula of density is known to you. Mass per unit volume 15,600 kg divided by mass 15,600 kg divided by how much is the volume? 2 meter cube. So what is that value coming? 15,600 to 7 the and 8. So what you are getting? 7,800 kg per meter cube. Now you have to find the value in gram centimeter. So you have to do the conversion, student. How will you convert? You know that what we know, 1 kg is equal to 1000 gram, student. Or by unitary method, what I say is equal to 1 unit is equal to 1000 gram per kg. This is called a unitary method, students. I can apply unitary method. So what is we are getting? 1 kg is 1000 and 1 meter is equal to, student, how much? 100 centimeter, or 1 is unit is equal to 100 centimeter divided by meter. So let us see the 7,800 kg. So what it means, student? If I multiply this with 1000 gram per kg, and then what is this? Meter cube. 1 meter cube is how much? 100. You have meter cube, student. Meter means 3 times, we have to do it 3 times. So meter cube means 100 centimeter divided by meter into 100 centimeter by meter into 100 centimeter by meter. So kilogram and kilogram cancelled. 3, 1, 2, 3 cancelled. Can you tell me what is the answer coming? Find the value. How much is this coming after cancellation? How much it is coming? How many? One, two, four, six. So 2 and 5. Then what will be the answer, student? Cancel, 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 and this cancels. How much it come? 7.8 gram centimeter inverse. So we can convert the, you see, one unit into another. Therefore, students, we can do the calculations of the density. We can do the calculations of the density. Any doubt? Any doubt, students?
No, sir.
Very good. You understood why we are talking of density. Okay. One more important thing here is, student, certain substances have more density, some substances have less densities, and we want to compare which is heavier, which is lesser heavier as compared to water. So we define another term which is called the relative density. We define another term, relative density, in order to compare, student, how heavier the object is with water we talk of the relative density of the substance. And that means relative density of the substance will is defined as density of the substance, density of the substance divided by density of the water, density of the water. So if I divide the density of the substance by density of the water, then I will get the relative density of the substance. What was the density if I have a substance? The density, the substance of density is, supposing the density of the substance is d1 and density of water is d2. This is my water. Then what will happen? This will become, relative density will become, relative density is equal to, then relative density will be equal to, student, density of the substance d1 divided by d2. D2 is the density of the water, and density is always for the same one. Volume is always the same. What is density? Mass per unit volume. So if the mass of the substance is, if the mass of a substance is m1 for volume v, for volume v, and mass of substance, mass of water is m2 for volume v, same volume, because in density volume has to be same, volume v, volume v. Then what it, if I put the values here, what it becomes? M1 divided by v, m2 divided by v. So what will be the result? This v will be cancel. What you get? M1 by m2. So the formula of relative density, students, becomes equal to m1 by m2, where m1 is the mass of the substance for volume v and m2 is the mass of the substance for the same volume. M1, m2 are the masses for the same volume, student. So by this method we can find the relative density to express the heaviness of a substance in comparison to water. So what is important to, first important point about relative density is to express heaviness of substance relative to water, relative to water. We can use the relative density. ठीक है? So when I say find the relative density, question, find the relative density of iron, and I say the density of iron is given, student. Density of iron is given to you in the exam, student. Density of iron is given 7.8 gram centimeter inverse. Density of water is a constant. You already know water density. What is the density of water? 1 gram centimeter cube, or 1 gram per milliliter also we call it. So then what will be the relative density of iron? What is the answer, student? What is the answer coming? That is the relative density of iron, 7.8 gram centimeter inverse divided by 1 gram centimeter. This is minus 3. Units cancel, 7.8. So relative density is a ratio of the density of the substance divided by density of the water. It has no units, no units, because it is a ratio of the two densities. It is only a number. It has no unit, student. It is only a number. Important point to note down. Important point to note down. It has no units. It has no unit, student, because it is a ratio of the density of the substance divided by density of the water. Therefore, you are trying to say that the iron same volume and same water, iron is 7.8 times heavier than water. Can you say like that? Yes or no? That iron is 7.8 times heavier if I take the equal volume of the water. So what we are saying, students, what we are saying, students, the result is that iron is 7.8 times heavier than equal volume of water. Equal volume of water. True? Sure?
Yes, sir.
Question, sometimes they give the question like this. They say the relative density of silver. Ag is silver. You are given the relative density of silver, student, 10.8. 10.8, student. Find the and density of water, 1000 kilogram meter inverse. Now he says find the density of silver. You have to find the density of silver, students. So how will you find this? A question which was given in the paper, student. So what will you do? What is the formula, student? What is the answer? What is the answer of the student? Relative density is equal to density of the substance divided by density of water. Right or wrong? Tell me. Is this formula correct? Did I write the correct formula, students?
Yes, sir.
Okay. What is the relative density is given to us? How much? 10.8. It is a number. It has no units. And you have to find the density of silver. And what is this value? What you are given, 1000 kilogram meter inverse. So what is then answer? What is the density of silver, students? How much? 10.8 into 10 power 3 kilogram meter inverse. What is this value? 10800 kilogram meter inverse. ठीक है? Did I do right or I have done any mistake, students? So by this method we can calculate the densities of this any substance, relative density is important because it tells you how much heavier is the object when you compare this, student. And interesting thing is that you have found in Archme this principle. What happens if a body is in water? Immersed in water. What happens? What it does? It displaces water. It displaces water. It displaces water. If a body is completely immersed in water, it will displace water, which will appear in the form of loss in weight, which will be equal to the weight of the body. So there is a what is important. The solid will displace. So if this is a solid, it is immersed in water. Immersed in water, student. It displaces water. It displaces water. And the volume of the liquid, volume of the water, the volume of the water, student, that will be displaced will be equal to volume of the solid object. Volume of the solid object. Right or wrong? So what is the volume of that? Equal volume of the water will be displaced. Equal volume of the water will be displaced. ठीक है? So the amount of water that will be displaced will be equal to the volume of the substance. The solid will displace. What I am trying to say, student, I hope you understood what we said here. Here, what we have shown you, that if you have water here, water here, water here, this is my water. What happens if I, students, if I put an object here, this is a solid, then what happens? It will equal volume of the water will be displaced. The water displaced, this is my water, which is displaced by this, is equal to volume of water displaced, ठीक है, by the object is equal to volume of the water. Volume of a displaced object is equal to volume of the object. Volume of the object. This is important point. We can use it. Therefore, students, what we have defined in today's lecture, density and relative density. So you can say that you have seen the density of ice is less than water. Density of ice is less than water. Therefore, ice will float or sink on water. Tell me. We have given the value of the ice and as well as the water also. The density of ice is less than water, student. Therefore, ice floats on water. Ice floats on water. Okay? Another important point. What happens that if I take iron, the density of iron is less than water. It sinks in water. It sinks in water. And if I compare the density of iron and density of mercury, students, what are the two values which we have, student? Which is heavier? Which has more density, mercury or iron? What is the density of mercury, students? What is the density of the mercury, which we have given the value to you, students? In our previous page, we have given somewhere the density of mercury was 13.6 gram centimeter inverse, students, and the density of iron we have calculated, and from L-8 book we have got 7.8 gram centimeter cube. Therefore, students, if I put iron on mercury, will it sink or float? Tell me. Will iron float on mercury or sink in mercury? Tell me. You have mercury, you put iron in it, will it float or sink? Tell me. Will iron float or sink in mercury, students? What?
Sir, it will sink.
Iron will sink. The density of iron is 7.8, density of mercury is 13.6. Which has more density? Which has more density? Iron or mercury? Iron density is less than mercury. Therefore, iron will float on mercury because the density of iron is less than density of mercury. This is 13.6, this is 7.8. Right or wrong? Tell me. Right or wrong, students? Tell me, students, is it right or wrong?
Yes, sir, right.
Okay, you have to think before you answer, students. All right, so this ends the density and relative density topic, which was very important, students. And we wish you a very, very happy Diwali. And we will meet you in our next class with a lot of question answer sessions. I hope this have been very clear what we have tried to explain to you. What is density, what is relative density, and what is the applications of this. And we will be meeting you in our next class. Okay, bye bye, good night, happy Diwali, students.
Thank you, sir. Happy Diwali to you too.
Okay, all the best.